Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're winding up this series, and on this installment we're going to be rebuilding the grid bias boards, which are the two boards that have the coupling capacitors and the potentiometers for adjusting the grid bias voltage. And as I will show you in the video, they're missing a very important resistor that will help keep this amp from melting down in the future, so don't miss that. And I really think this mod's probably one of the most important ones to do in this amp, so let's get busy. Okay, the next thing we're going to be working on is the modification of what I call the bias boards. And there's two of them. There's one on this side, there's one over here. They have the potentiometers on them for setting the bias. They also have the coupling caps that go between the phase splitters and the output tubes. These are probably the most sonically important capacitors in the amp. There's also a couple of electrolytic caps that we're going to be replacing with some audio note ones. And also in this process, we're going to be putting some grid stopper 1K resistors between these wires and the grids of the output tubes. And I'm going to go ahead and replace these wires with some 18 gauge solid core wire. I've already done this channel and listened to it, and everything worked great. We're also going to be doing another modification, installing a 100K failsafe resistor to these boards, so that if for some reason the wiper of the potentiometer fails, the tube won't go nuclear and melt down the amp. It'll simply apply the full negative bias voltage from the negative bias power supply, which just shuts the tube off instead of it red plating and melting and blowing up other stuff inside the amplifier. So we're going to pull these boards out to work on them, and there's just a few wires holding them in, so I'm going to zoom the camera in and show you how to remove these boards first. So the first thing you want to do is take this screw out that's holding the board down. And then go ahead and just stick it in one of these extra posts, like this one right here, so you don't lose it. Okay, so once you get the board unscrewed from the chassis, you simply come in here and heat these wires up one at a time and disconnect them from this board. And then there's this one. And then we have these two wires here that go over to the power supply. The white is the negative and the black is the ground. And then what I would do, just so you don't get confused about where these wires came from, go ahead and unhook them over here at the tubes. And you know the short wire goes to this tube and the long wire goes to that tube. Like that. So you know which wire goes where. And now that we've got the board all unsoldered from the chassis, we will work on the board on the bench and do our mods to it there. Okay, so now we're going to come in and start working on this board. First thing I'm going to do is remove these two electrolytic caps. You just kind of heat up that pad and push over on the cap. And then do the same thing on the other lead. And it lets go. So we're going to remove this one. That. And then, okay, two caps are gone. We got these two film caps. We want to do the same thing with them. You just kind of pull on one lead while you're heating up the solder. And then come in here and Heat that one up. Pull it out. It really doesn't matter which order you do this stuff in. And you see me replacing a ton of other resistors in this amplifier. These seem to be pretty nice quality. I see no reason to be replacing these resistors. So we're going to leave those alone. Last thing we're going to do is remove these wires since we're going to be replacing them. Heat that up. Now we want to come in here with some solder and tin the end of this wire a little bit. Well, this wire is supposed to be already tinned. It's not going to hurt anything to put a little fresh tin on it. We heat the board up and slide this wire in through the hole. Just like that. Pull this one off. And replacing these wires are optional. I just prefer to use solid core wire over stranded wire, as it keeps its shape better when we're putting it in place. So there we go. Got our two new wires on, got our components removed. Now we need to clean these holes out so we can put our new components in. And there's various ways of doing this. One of the things I've had good luck with is just using like your basic can of compressed air, right? And come in and heat up the little solder pad and blow the solder out. And I'm not going to show you like all the holes doing this, but you get the idea. So I'm going to blow all these holes out and then come back and we'll start installing components. Okay, once you've got all that done, there might be some solder splatter on here. Just get your fingernail and kind of scrape it off. The solder's not going to stick to this, the non-copper part of the board. So you can just come in here and just kind of scrape it clean. And then you've got all your holes opened up so you can install your new components. And probably wouldn't hurt something to get a rag and wipe it down too. Check both sides, make sure you don't have any like solder splatter from blowing those holes out. And I mean, you can use a solder sucker, you can use those little wick things to pull the solder off if you want to do that. I've just found it easier just to use some canned air and blow the hole out and blow the solder out of the hole. So anyway, let me wipe the board down and we'll get ready to start soldering the new components in. So one of the things that bothers me about this bias board is there's no what I call failsafe resistor. The way this board's made, and I'll show you in the schematic, if the wiper of one of these two potentiometers goes open, like gets some dust on it or for whatever reason isn't making a connection, the grid no longer has negative bias on it. The output tube will go nuclear, red plate, and blow out the cathode resistor, probably destroy the output tube, and could potentially destroy the output transformer. The voltage pathway on this board is we have the negative voltage here, comes up this trace, and it goes to this side of these two 1.2K resistors. Then they come down here from this terminal to here and put power on this side of the potentiometer. This is the ground side that then goes through this resistor. Then the other side of this goes to ground. And the same thing on this side over here. This is our negative voltage. Goes through this 1.2K resistor to this terminal. Then it goes from this terminal to here. The center point comes over here to this 100K resistor that then goes to the grid of the output tube. The signal comes in here, goes through this coupling cap, and also to the grid of the tube. So what we want to do is connect this pin here, or this terminal here. Voltage comes in, goes through this 1.2K, so we have our full negative voltage right here. We want to put a 100K resistor between here and here, which is the center point of the pot. So if the center point of this potentiometer ever goes open, we have a pathway for the full negative bias to go from this pin to the grid of the tube through this 100K resistor. So we're going to add another 100K resistor between here and there. And even just a little 1/4 watt resistor is fine. So we're going to be using these little small 100K resistors. So we're going to bend this guy up like this so it goes across just like that. And let me zoom in here so you can see that a little better. It's going to go just like that. Let me get this trimmed like I want it. And I'm trying to keep this on camera as much as possible while I'm trying to put this in place. And it's going to sit in there just like that, except hopefully a little more parallel to that resistor next to it. And this is going to be tricky to try to do on camera and also do a nice job of it. So really trying to do this on camera that's like looking at the camera that's a mirror of what I'm soldering, but I think I got that one soldered good on that end. And then let me come back in here and do this joint a little better. Like that. It's fine if you leave a little blob. So this is what it should look like when you're done. You're connecting that pin to this pin with this 100K resistor, and now if this potentiometer ever fails, it will just go full negative bias on the tube, which should put it about -70 volts, which just pretty much turns the tube off, instead of going to an open pin where the grid has no negative bias on it and the tube red plates and it just melts the tube down. I'm going to go ahead and do this other side over here, and then we'll install these two electrolytic caps and the coupling caps, and we'll be done with the board. Okay, so the next thing we have is we've got these two 100 UF 100 volt caps, and I'm using some audio note ones, which are some nice quality. These are their, I guess, kind of their budget versions. They're, they're not cheap, but they're not stupid expensive either. You don't need to be using $75 capacitors for this. And honestly, I don't see the point in putting super high cost capacitors in these amps anyway, given that we don't really know what the output transformers are, and they're probably the bottleneck in this amp. So it seems, at least to me, kind of silly to be installing some, $200 and $300 worth of capacitors in an amp like this, given that they're probably $100 output transformers that we're working with. So anyway, again, because this is a negative bias, you're going to be putting the positive side of the cap towards the ground. And the board is marked which side's positive. And just remember that the negative stripes are going to go towards the outside of this board. So put these two caps in, then turn it over and bend these leads over like that. So it'll hold the caps flush up against the board. And realize that these go on the top and the potentiometers are on the other side. Don't put them in backwards with the caps on the same side as the potentiometers. And then we want to come in here and kind of helps have something to keep the board from like walking away from you. And you may have some custom little stand for your boards or something to work on. Come in here with a clean tip. And 032 solder works really good for this kind of work. Heat that up. Make sure you get the trace on the board warm and you're not just putting the solder onto the wire. That's really important. To make sure the tip's contacting the board so the solder is flowing in the joint and you're not just piling some solder up on the lead. Like that. You come back in with your flush nippers, cut those leads off like that. The next thing we have are our nice aluminum oil Mundorf caps. You can do whatever you want to use. I like these caps. They're fairly reasonably priced. They're about $15 to $17 each, and they're a nice compact size. And just for comparison's sake, this is the 0.22 UF 450 volt Mundorf cap we're going to be installing, which is 450 volts plenty. We don't have anywhere near that voltage. Here's the 0.22 UF 630 volt that came out of it. So you can see, easily replace that. We come in here and compare it to some MyFlex caps. Here's a 0.15 UF 250 volt. And you can see, huge. Go up to a 0.33 UF and we got a monster size cap, and it's a 250 volt. If you need 600 volts in 1.5 UF, that's the size of the MyFlex in that. So as you can see, you're going to have a really difficult time. They're not going to attach on this board. You're going to have to put them somewhere else and run wires over there. And honestly, listening to them, I prefer the sound of the Mundorfs. So again, before we jump into installing these coupling caps, I want to show you these failsafe resistors one more time. There's the one on that channel. There's the one on the other channel. And you just want to make sure you get a good solder connection on each end of that onto the tail of these other resistors. And like I said, that'll help keep the amp from ever imploding if the potentiometer fails, which I've read has happened on some of these amps. And their solution is just send you another board and some output tubes and the cathode resistors. So the direction that these go in, we want the outer foil going towards the phase splitter. And on a Mundorf cap, that's the short lead, and you want the signal going through in the direction of the writing is an easy way to remember on these caps when you're putting them in the coupling position. So they're going to go in like this, and I bend the leads up so they look like that. And I want it sitting about like that with a little bit of gap between the capacitor and the board. So then we bend these over, put something under there so they're kind of hanging down and not getting pushed up through the board. Solder one side down. And again, you want to put the tip up against the board. Make sure that you've got the board heated up, and then feed the solder into the joint just like that. And then when you're happy with it, you got a nice little gap there so it's not right up against it. You got it even. Trim your leads off. And then you have your capacitor installed. So I'm going to go ahead and do the other one, and then we're ready to put the board back in the amp. So now we're ready to solder this board back into the amp, and it's just the reverse of what we did earlier. First, we want to hook up these two leads that come over from the phase splitter. And we'll get the leads to put in like that and that. Come in with our solder. There's that one. And again, like I've warned you in the past, be careful with the body of the iron that you don't like lay it up against one of these caps and burn a hole in the side of it. Then the next two we got to connect are these two leads right here, and one of them goes in the ground, the black, and then the white one goes into the marked V minus for negative voltage. Solder those two back in place. Then we just want to get these leads kind of out of, I put the two power wires up through the center like that. And then put this board back in place and screw it back down. And you don't need to get this screw crazy tight. You just want to give it a good snug so the board doesn't move around and end up falling out. So the last thing we got to do is hook these leads up to the grids of our output tubes, and we're going to be installing a grid stopper on these tubes, which is a 1K resistor. And the way I do it is I come in here and cut these off real close. And ideally you want this resistor as close to the terminal as possible. So you want it something like this, where you got the resistor right close to the pin. And then we're going to bend that up just a little bit, because this is going to come over and connect just like that. You want to trim off a piece of heat shrink tubing about that long, so we're going to cover up the resistor and the joint. Slide it up the wire like that, get it out of your way. Then with those two bent over where they're right up next to each other, you come in and solder this wire to the end of that resistor, just like that. Then slide this piece of heat shrink tubing down, and then I just use the body of my soldering iron to shrink up the tubing. And some people use a gun, but I've found that works fine. And then you just shrink that tubing up around that joint and the resistor, and you're all done. So we're going to do the same thing over here on this side, and we're going to have a much shorter wire over there. That. Trim off this little extra, if there is any. Strip that back. Slide our heat shrink tubing up and over like that. Get those two laying up against each other. Solder those two together. Like that. And then shrink that up. And that just helps reinforce that joint. So there we go. We got the board back in. We got our wires laid out nice and neat, going across like this. Got this channel, that channel. Got our grid stoppers going to our tubes, our new caps. Got our failsafe resistors put in, and our new electrolytic caps on the ground side of the potentiometer. It's a good place to wrap it up right here. Well, as you can see, this isn't a real hard mod to do, and I hope you understand the importance of this safety resistor that we put in here that makes sure that the grid never goes open. Because I really don't understand how they could design that grid power supply and leave that important resistor out, but they're not the first manufacturer to do that. Honestly, this mod is probably the most important for reliability, and also it's going to make the most sonic difference by upgrading those coupling caps. Even if you don't do that other 0.33 UF film cap that's on the tail of the phase splitter, this one's going to make more difference. And so these 4 caps, and then go ahead and replace those other 2 electrolytic caps while you have the board out. Put in those safety resistors, put the boards back in. That's probably going to make more difference than any of the work we've done up till now, as far as something you're going to actually hear when you're playing the amp, plus the reliability of it. These other resistors and stuff I replaced, yeah, I'm concerned because they keep cracking, and some people are saying it's from rough handling, or I don't know, but they shouldn't be doing that. And I know these Vichy metal film caps aren't going to have that issue. Whether they're going to fail or not, I don't know. It just seemed like a problem to me. Same with the choke, same with those 450 volt rated caps. Are any of them going to blow up tomorrow? Probably not. But I have heard reports of these grid boards failing from the potentiometer going open, and then the tubes going nuclear and melting the amps down. And so, again, if I was going to do one mod to the amp, I would do the one in this video. It's not hard to do, and I really think that it's going to make this a much safer amplifier, and it's going to improve the sound of it. As far as using some of those MyFlex caps or some of these other copper foil, giant caps that are the size of these, 330 UF 450 volt power caps, I just don't see the value in it. If people want to do that, that's fine. And this is a hobby. Not going to ditch you. But as far as feeling you need to do that, it's not necessary. These Mundorf caps are going to sound great. And I think you'll really like the difference that they make in the way this amp sounds. So anyway, hope you're enjoying the series. If you are, please sub to the channel. Please consider joining my Patreon. Also have a donation page at my website that helps me keep rolling on projects like this. And until the next video, have a nice day.